Good morning, everyone. Yesterday we started with our discussion on pointers. We saw the concept of a pointer. We also saw what is the actual relationship between a pointer and an array. So, specifically 1D arrays. Okay. So, we'll continue with our discussion today. Okay. We saw some pointer arithmetic as well. So, like if P is a pointer to an integer. Okay. If P is a pointer to an integer, how will I declare it? It will be in star P, right? This is the way I declare a pointer to an integer. And if I make this integer pointer point to the base address of an array, how do I write that expression of a 1D array? P is equal to A, right? Or P is equal to address of A of 0. These two expressions are equivalent. So then I can perform some pointer arithmetic, like I can add some constant locations to it. I can do a P plus plus, okay, and I can update the pointer P plus plus. I can also do a P minus minus, okay, and we also saw how pointers and arrays can be interchanged. So I can do the same indexing using the P variable as I do using the A variable. So if P is pointing to A, if I say P of 2, this will be equivalent to A of 2. So that is how they are interchangeable. Okay. So one thing to note about pointer arithmetic is you can do these operations, these are perfectly valid, but you cannot add, you can also subtract. So if there are two pointers, P1 and P2, which are pointing to, which are integer pointers, so I can write a P2 minus P1. So I can subtract the addresses. Okay, because each of the contents of these pointers are addresses. So I can do a subtraction, but I cannot add. This is not allowed. This is not a valid expression as far as C is concerned. Okay, you cannot multiply, you cannot divide, you cannot multiply, you cannot divide. Okay, these are also invalid. Only these are valid expressions. Okay, so you have to be careful about pointer arithmetic. Only these are the allowed operations. You can subtract the addresses, you can add constant to a pointer, constant address to a pointer if it is pointing to an array. You can do a P plus plus, P minus minus. Okay, you can update it. Okay, one more thing is arrays are constant pointers. If my array is A, I cannot do an A plus plus. That also we saw last time. This is also not allowed. Or A plus, A is equal to A plus 1. Not allowed. This is not allowed. This is not allowed. Okay, so this was about yesterday's lecture. So today we'll be seeing the following topics: pointer to a 1D array, pointer to a 2D array, pointer to a pointer, array of pointers, and pointer to a struct. Okay. So first of all, let us see what is a pointer to a 1D array. This is my 1D array, right? In memory, it looks like this. So pointer to this 1D array basically has this syntax. Look at the syntax carefully. So the data type followed by into parenthesis. This is important. Into parenthesis, your pointer, so star PTR, whatever name you want to give it, star PTR, and the size of the array in square brackets. This size has to match the array that it's going to hold. So this pointer can hold any array whose size is 10. Okay. So this is the syntax for declaring a pointer to an array. This is a pointer to an array. So what do I mean by a pointer to an array? A pointer to a 1D array to be specific. Okay. This means that this pointer is pointing to the entire array. So the entire array B is considered as a whole, a single thing, single entity, and this pointer is pointing to the entire array. Okay, so how do I make it point to this array? So now I'm first of all I've declared it. So the first part was declaring. How I make ptr point to array b? I say b is equal to pointer is equal to address of b. Okay, it is not address of b of 0. Remember, it is pointer is equal to address of b because it's the entire array, address of the entire array. Okay, so this entire array is treated as a whole. This entire array that is there, it is treated as a whole, and it is having an address. Okay, now what do you understand by this expression, address of b? Address of b will give you the address of the entire array, and remember, the address of the entire array is always the address of the base element. So if I want to refer to this whole array's address, it is this. Okay, so the address is same, but the type is different. When I say address of b of 0, and when I say address of b, the type of these the type that is there of these expressions is different. This means it is address of the first element of the array, and this means it is the address of, sorry, address, this means it is the address of the entire array. This means that it is the address of the entire array. So if it means the address of the entire array, which variable can hold it? Only a pointer to the entire array can hold it. That means I cannot have something like another pointer like this, int star p, and I cannot say p is equal to address of b. This expression is invalid. Why? Because the type of p is int star. That means it is a pointer to a single integer. P is a pointer to a single integer. On the other hand, this expression is valid because pointer ptr is a pointer to the entire array because of this syntax. Look at the syntax difference. Okay, so understand this concept first, that when I have an array, and if I create a single pointer to an integer, it can hold the address of a single integer. Okay, and when I want it to point to an entire array, if I want to hold the address of the entire array, I need that pointer to be of 10 locations. Okay, that the size that will be equal to the size. In this case, there are 10 locations, so that is why this is 10. If there are 5 locations, this has to be 5. It has to match. The size has to match exactly. Okay, now when I do a p plus plus, since p is equal to address of b of 0, when I do a p plus plus, what do I get? P is this, right? For p, for my pointer p, what do I get?
Address of b of 1.
Yes, so you are simply incrementing it by one location, so it will point here. Okay, but when I do a ptr plus plus, what will I get? I will get, actually my pointer will be incremented by the size of the array because it is pointing to the entire array. Are you getting it? So ptr plus plus, ptr is this. Ptr plus plus will increment directly by the size of the array. It will point to the next location after this. That will be, what will be this? It will be 1040, right? Because this, the last integer will take 4 bytes. Okay, so ptr plus plus is going to give me 1040. So understand this concept, that pointer to an array and pointer to an int, pointer, this is pointer to an integer array, right? Ptr is a pointer to an integer array and p is a pointer to a single integer. So these are two different things. Okay, so once we understand this, let us see how do we dereference. So what happens when you use a dereference, the star operator, for this pointer to an array? What is star ptr? Okay, so star PTR is the same as star of address of B. I just replace with PTR with address of B, right or no? PTR was equal to address of B when I initialized it. It was not address of B of 0, it was address of B. Yes or no, everyone? So I
Yes,
just
ma'am.
Yes, ma'am.
replace it, and now these two operators again they are complementary, so they cancel out. And what do I have? B. And what is B? B is the array name, right? What do you understand by array name for a 1D array? It is address of the first location of the array. Correct? So if I write this expression star PTR, I get B. And since B is equal to star address of B of 0, star PTR actually gives me the address of the first location of the array. Are you understanding the difference? Earlier, star P was giving me a value because it was directly pointing to an integer. But now PTR is pointing to the array, entire array. So star PTR is going to give me the address of the first location of B of 0. Now, what if I want to get the value at this location? What will I need to do? Can anyone tell me?
We'll again put one star for dereference.
Very good. So I just put one more star before star PTR. So star PTR is going to give me B of 0 because this will be star address of B. This will get cancelled out. Okay, and then star of B, and star of B is star of address of B of 0. Again, this will get cancelled out and you will have B of 0. Okay, so you make use of the dereference operator again to get the value at the first location.
Ma'am, what if we print a PTR?
When you print PTR, what is
In case of
PTR?
pointer to an array?
What is PTR? Address of
Address
B.
of B.
Address of B. Address of B is the address of the entire array, and address of the entire array is also equal to the address of the first location
First
of the array.
element.
The address is same, but the type is different. That is what I'm trying to say. The type of this and the type of this, they are different.
So star
This means,
PTR and PTR will print the same thing, no?
yes, they are going to print the same thing. Very good. Good question. They are going to print the same address.
Okay, ma'am. Thank you.
So this example is here. You can check. This is an array of 5 integers. It created a pointer to array of 5 integers. Okay, and this is a simple pointer. And then if you run this example, like start with all the values, you will understand how it works. The same thing, whatever we have discussed, is there in this example. Please run this example later on. Okay. One more thing is, I wanted to discuss the programs of related to pointers and arrays before we move on to this pointers to 2D array. So let me discuss those programs before I move ahead. So first program is to swap the largest and smallest and largest element in the array using pointers. Okay, so this program, these two programs that you see here, they are related to the first lecture that we had, that is pointers and arrays. It is okay. So let me see where it is. Yeah. So using the same concept, what I have done right now is I have actually defined all the functions for the array. So consider one array. This array can be taken from the user. When you are doing the program, you can take the array from the user. And yeah, so this is the array that I'm going to take. This is one more arbitrary array. This is okay, but this is the array which I'm going to take from the user. So for that, there is a function called as read array. Okay, read array, everyone knows how it looks like. Print array, you know how it looks like, right? So for read and print, now instead of the usual notation, what we have done is we are using the pointer notation. So here I have simply used x plus I for reading. You understand why? X plus I. X plus I is the same as address of x of I, right?
Yes, ma'am.
So, and for printing, I'm using star of x plus I, right? Yesterday we discussed all these expressions. Now, if you want to swap the smallest and the largest, what should the logic be? You simply do the comparison, right? So there is one function which I have defined in this program, that is swap small with large. So again, here I have used a different prototype. Understand that this prototype and this prototype is one and the same. So far, since we were not introduced to the concept of pointers, we always use the single bracket, a square bracket. You can also use this because anyways, what you're passing as an argument is the address of the first location of the array name, right? When you're calling these functions, you're passing the array name. Array name means the address of the first location. So that is why the type of that is int star. Do you agree with this? The type of that address is int star. Okay. So now once you do this, it's a simple, what do you say? A simple function that you have. Logic is not very difficult. So what you do is you have to only use pointers. That's the difference from the normal variant. So we just create 2 pointers here. This is one way of doing it. There could be a number of ways of doing it. One pointer is called the largest pointer L. L is the largest element. S is the smallest element. And what you do is initially both the pointers point to the base address. Okay, and then you just go through the entire array. So this loop is for going through the entire array, and as you're going looking at each element one by one, you are comparing that element. So how to compare the element? Star of x plus I, right? Are you getting this? Star of x plus I is going to look at that element one element at a time and going to compare with this value. Okay, so if it is less than star of s, that is the value which is there at that, then s will point to x plus I. Okay, s is going to be updated to x plus I. Similarly for L, if it is greater than star of L, because L is going to contain the largest element, s is going to see at the end of this loop, s is going to contain the smallest element, the address of the smallest element, and L is going to contain the address of the largest element. Fine. So you simply are going to update the address. How do you update the address? Initially it was x, address of x of 0. Initially the address for both L and S was the first element, and as you are proceeding with the array, you will surely find some element which is either less than S or greater than the element at L. So how do you update the address? S is equal to x plus I, because x plus I is the address of the element star x plus I, right? Is this logic clear to you, or you want me to explain more? Yes?
Understood, ma'am.
Yeah.
Understood, ma'am.
And then finally you swap it. So this is the logic for swapping. Temp is star L is star S, and star S is T. This you already know. Okay, so this is one of the programs. And then there is one question for reversing the position of element in the array using pointers. So it could be any array. It could be array of integers. I've used array of characters. I've used a string in this example. So if you want to work it on an integer array, you can just modify it to array of integers. Where is that? Okay. Okay, I close that program. No, it is not this. Just a minute, I'll just open it. I'll open this one. Yeah. So this one. So for this, what you do is reverse logic for a string you know already, right? Two character iterators you're taking from both ends, or for any integer array you know the reverse logic, right? And then you keep on swapping. How to reverse? From one end you have one iterator, from the other end, from the end of the array, from the beginning and from the end you have two iterators, and as you're going, one will go to the right, one will go to the left, right? And as you are going in these opposite directions, you're swapping the elements. You have done the palindrome logic similar to that, it is, right? So for this particular example, we, instead of taking those iterators as normal characters, we are taking them as character pointers. Okay, so char star L star R. So L is initially S, that is the base address of this string. Okay, and R is S plus N minus 1, because you're passing N also. So you know what is N? N is the length of the string. So S plus N is going to give me one character more extra, so minus 1. So you start from that character, and then because that will give me the null character actually. S plus N is going to give me the null character. Okay, so then you simply just do an L plus plus and an R minus minus, and here you're doing the swapping logic. That is what you're doing, correct? So I think this example also should be clear. You just swap the characters, right? Left to right, just swap one by one. That's it. I hope you're able to visualize this, because H will be swapped with O, E will be swapped with L, L will be swapped with L. That is how it is going to happen till it reaches the center, right? So that is why the stopping condition is while your the continuing condition is while your L is less than R. The moment it becomes equal to or greater than, you stop, right? So that is the reverse logic. So this is for a string. You can do it similarly in a similar fashion for the integer. So one thing to note here is, here we have used the size of operator to pass to find out the length of the string rather than string length function. So what did I do? I passed to size of the address, the size, the string, the entire array. So this size of str is going to give me the size of the entire array in bytes, right? So what will be the size of this? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, right? 15 divided by size of char is 1, but if it is an integer array, this will be useful for you, this expression, right? So this is 15 divided by 1, that is 15 minus 1. That is 14. Y minus 1, the null character also I counted as one of the characters. Okay, that is how it was 15. So it is 14. And then, so that is why how you pass it here. So this is one useful expression which you can use for finding the length of any array. Any array you can find. Okay. Have you
Ma'am,
understood this example?
I'm just one doubt. If you're accounting for the null character in the like length of the string, then why are we doing s plus n minus 1? Is it because you're starting from 0? That's why. Because there, though, we don't need
No,
it.
null character. See what I have done is I have used a string length. This is actually giving me the string length, because string length function returns me the length of the string minus the null character. You know that, right? String length function,
Yes,
str
ma'am.
length.
Yes.
So this is the same logic for string length. So it is giving me that, and if it gives me that, so it's going to give me 14. But the index at 14 is a null character, because my array indexing actually starts from 0. Length is 14 minus the null character. Are you getting it?
Yes, ma'am.
Length.
Understood. Yeah.
So it has to start from 1 previous to the null character. That is why minus 1. So
Understood.
this is about, yeah. So this is about the second example. So I think these simple examples using pointers you can do. So any one of this will be you can do in the lab. Okay. Whatever your batch professor tells you, these are the 2 examples. Out of these, any one will be asked. And let us now switch back to our 2D arrays discussion. Okay. So everyone knows this is how a 2D array looks. Okay. So this is your 2D array example. In memory, it will look like this. And just recollect that a 2D array is an array of arrays, array of 1D arrays. So it is like row wise, they are stacked one below the other in memory. That is what is happening, right? This is the first row. Yes or no? This is the first row of this array A. This is the second row. And this is the third row. So by performing row wise stacking, so memory is going to be vertical, right? So it is going, what happens inside memory is vertically only it is saved. So first 3 elements, so it is starting at 1000. So 5, 2, 1. So then after this, immediately this is saved, right? That is what is happening. So 2D array actually is nothing but an array of 1D arrays. This concept is just a revision of the concept of 2D arrays. Okay. So when I talk about a 2D array A, now forget that everything about 1D arrays. Just remember the pointer to an array, that concept. Okay. Now this array A is a 2D array. It's no longer 1D array. So it's an array of 1D arrays. Okay. So each of these arrays which are there, they have a name actually. So first array has a name A of 0, right? So each of these arrays, this row is an array, this row is an array, and this row is an array. Each of these 1D arrays have names. The names are A of 0. The name of the first 1D array is A of 0. The name of the second 1D array is A of 1. The name of the third 1D array is A of 2. Okay. So if I want to have a pointer which points to this 2D array, I cannot write something like this. Okay. If I want to have a pointer to this 2D array, what I do is I make a pointer which points to the 1D array. Okay. So basically what I do is the pointer type, the type of this is star of P of 3 is equal to A. So when I say star of P of 3 is equal to A, I can hold the address of this array A. Okay, because understand that in star of P is simply a pointer to an integer. So I cannot write this expression. This expression will be invalid. This will give me a compile time error. Okay. So what I do is I use my earlier concept of pointer to an array and I say star of P of 3 is equal to A. What do I understand by this? Why 3?
Because there are 3 elements.
Yeah, there are 3 elements. Each of the 3 elements are arrays. Okay. So the type of this A, expression A, is basically a pointer to a 1D array. Okay. So we will look at this concept. This is a little tricky concept. You might not get it in one shot. Okay. Let us understand this with an example. So if I write the expression A, what do you understand by that? It is the base. When I say A, it's the name of the array. The expression A is the name of the array. Yes or no? Array name written as it is. You are writing the name of the array. A is a 2D array. It means that it is the address of the first element of the array. The array name written as it is means that it is the address of the first element of the array. Yes or no?
Yes, ma'am.
And what is the first element of this array? It is A of 0. What is the first element of array A? It is A of 0. So, what will you get as the answer? A of 0 is an array. Address of A of 0 will be
an element.
So it is going to be 1000 because again I am saying address, this array's address. This array's address. That is, it is pointer to this entire array. This is a pointer to the entire array. Okay. Remember that concept. Address of B likha tha. PTR is equal to address of B. And B was the name of the array. Now in our case, A of 0 is the name of the array. A of 0 is the name of an array. Are you getting it? A of 0 is the name of this array. So address of A of 0 is a pointer to this array.
Yes, ma'am, got it.
That means it is the base, whatever is the starting location of this array, that will be the answer of this expression. Okay. When I write star A, when I write the expression star A, what will I get? So again, you use the dereferencing. You will, these two will get cancelled out, right? This and this will get cancelled out. So you will get A of 0. And what is A of 0?
Element.
Element. But this element is an array. Array name written as it is means address of, this is the array name. See, understand the difference. These expressions are different. Are you understanding? Address of A of 0 and A of 0. These two are different expressions. Okay. What is A of 0? It's the array name. Array name, this is the array name of this 1D array. Array name written as it is means address of the first element of the array. That is address of A of 0, 0. That is 1000. Okay. So this also
Can you repeat?
Yeah. Address of A of 0. So is going to give me the address of this, whatever is given to on the right hand side. But this A of 0 that I've written is the name. This is the name of an array. Yes or no? That means it's similar to the expression that we saw earlier, address of B. ऐसे था ना B. B, where B is an array.
Yes, ma'am.
हाँ. So what is the meaning of this? This expression? This expression will return a
Address.
point. Yes, yes. A pointer to this entire array. A pointer to the entire array of 0. And what is a pointer to entire array of 0? It is the address of the first location of A of 0. Okay, that is why you are getting 1000. Now in the second case, A of 0, when I am writing only A of 0, that means it is the array name of the first array. That is, it is A of 0 is the array name. It's an array name. It's similar to writing B. Let us assume it is B, and B is an array. So what is this expression equivalent to? Address of B of 0? Yes or no?
Yes, ma'am.
Yes,
and
ma'am.
that, so how will you interpret this? Address of A of 0, 0. I'm just replacing, assume, just take a alias that A of 0 is B. Let A of 0 equal to B. So this expression B is same as address of B of 0. And this B is nothing but I'm replacing it back. A of 0. Are you getting it?
Yes, ma'am.
So it is address of A of 0, 0. That is address of the first location. So that is what I'm telling. These two expressions, although they are giving me the same address, the type is different. What is the type of this? What is the type of this? It is a pointer to an integer.
The lower one is pointed to an integer, no?
Yes, this one.
Yes.
This is pointer to an integer. What is this? Pointer to an array of integers. Understand this, right? In that expression. What is this expression now? A plus 1.
Next index.
Next array within the array.
Next array.
Next
Yeah.
linear
Next
array.
array.
Oh.
Very good. If you remember the last point that I made, P plus plus, right? It will point to the immediate, it will go one array ahead. So this is A plus 1. That is 1012. Are you getting it? You can just interpret it. Address of A of 0 plus 1 is address of A of 1, but A of 1 is an array. Same logic which you applied earlier. So A of 1 of, address of A of 1 is going to be the address of this entire array, the type. Okay, that is how it is. 1012. Next. Okay. Star of A plus 1. Star of A plus 1.
Address of
Element.
first element.
Yes. So answer will be same. Type is different. Understanding, na? Star of, now if you want to go within that array, we are only talking about base for each array. Array 0 का पहला देखा, array 1 का पहला देखा, array 2 का पहला देख सकते हैं. Okay, but if I want to go within that array, so I want to go look at this element or this element, then I need to use something else. So what do I say? Star of A plus 1 plus 2. If I say star of A plus 1 plus 2, what do you have?
Address of the second
A of
element in
1,
the second
comma,
array.
Yes. So within this array, within this particular array, you advance by 2, right? So that is going to give me 1020. Address of A of 1, 2. Okay. Now next is star of A plus 1. This expression. You always you use your logic of using the reference operator. You know A is address of A of 0. Use that logic. That is why I've shown this explanation here. So it is star of address of A of 0. Then this gets cancelled out. Plus 1. And then you have A of 0 plus 1. But A of 0 is the array name, right? A of 0 plus 1. So A of 0, again you replace array name with address of A of 0, 0. And then plus 1. Okay, you just follow this sequence. So you will get address of A of 0, 1. Okay, and these two operators complementary cancel out. So you are left with the element. So you are seeing how the double star has come now, and you are getting the element at this location. Is this clear? I know it's a little difficult to understand, but you will need to go through this example once again. Okay. What is A of 1? We use that pointer notation now. Now we will use array notation. What is A of 1?
Second array, address of second
B
array.
of 1.
Correct. Correct. It is the address of, it's the array name na, for the second array. That means 1012 should be the answer, right? It's A of 1 is the array name. Array name written as it is means address of, okay, which is nothing but 1012. What is A of 1 plus 2?
1020.
1020. Very good. So it is 1012 plus 2 addresses, right? So that is 1020. What is star of A of 1 plus 2 now? Just
4.
star it. 4. Okay. So you get 4. So this is also one way of getting the elements. Now, what do you understand by this now? This expression that you have here, and this expression, they are equivalent. Yes or no? Star of A
Yes,
plus
ma'am.
1 plus 2 is the same as A of 1 plus 2. Okay. And if I put a star here outside, so if I write something like star of star of A plus 1 plus 2, something like this if I write. Okay. It will be equivalent to this.
Yes, ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
So this is the end result of this discussion. I wanted to derive this expression so that we can use an example of 2D arrays and pointers. Okay. This is another way of visualizing it in the matrix form. So A is the first array. This is fine. I think you have understood the concept. So I'm not looking at this. This is another way of visualizing it. So A plus I it points to the ith 1D array. Okay. And star of A plus I is the same as A of I, which is the base address of the ith 1D array. Right? That is it points to the 0th element of the ith 1D array. A plus I. Star of A plus I. So these are the expressions that we saw. A star A plus I. You should know what each means. So A means it points to the 0th 1D array. Star A means it points to the 0th element of the 0th 1D array. Are you getting it? A plus I is it points to the ith 1D array. Star of A plus I means it points to the 0th element of the 1D array. Okay, it is pointing. It is not the value; it's the address. Again, this expression also is an address. So within that array, the jth location, jth element, right? Within that 1D array, the jth element. That is this. And then finally star of star, which will give you the value. Okay. So understand, if you want to get the value, that means the expression Aij, if you want to get Aij, that is a value of any element in a 2D array, then you need to write star of A plus I plus J. So this is the expression which you will be using for the program on pointers and 2D arrays. Okay. So let us see that program quickly. It's on matrices. So matrix operations program. So similar to the 1D array counterpart, here what we have is read 2D array, print 2D array, and so on. Okay. So here we are using the pointer notation everywhere. Here you doing it using pointers. The star of p plus I plus j is going to give me the address at that, right? Address of pij. This expression is equivalent to address of pij, and star is equivalent to pij. This is for scanf. This is for printf. Are you understanding this? The same expression I picked it up from there and put it here. Okay. And then for matrix multiplication you can do, or addition you can do. Okay. Here I have done matrix multiplication. The logic is the same. Only thing is, instead of the array notation, you're using the pointer notation. So what you're doing is ijk 3 loops which are there, and wherever the arrays here to be multiplied are p and q. Okay, and r is the result. So p and q that you have, how will you multiply them? Using pointer notation. You will use that star of p plus I plus k, right? It is pik. What is the expression? Pik qkj. I've written it down. See, yes or no? If the matrices are p and q, the expression is pik into qkj. Everyone knows this, right? Matrix multiplication. So what we do is we simply replace this with the pointer notation that is there in the first line. Fine. And similarly, if I want to use r also with the pointer notation, instead of rij, because the element is going to go into rij, I say star of r plus I plus j. Right? Is this clear? Is
Yes,
this clear?
ma'am.
Yes. So this is about 2D arrays, pointers and 2D arrays. This much is enough for pointers and 2D arrays. And whatever I discussed, the programs, this is part of your experiment 9. For 1D arrays also I discussed, 2D array also I discussed. One of the programs from 1D array and this program from 2D arrays. It could be addition also of two matrices, the same notation you have to use. Okay. Then I will stop at this point. I just want to take this one topic and then I'll stop. But I wish to continue this discussion today at 4 o'clock. Okay. First, let me complete this topic. Pointer to pointer. Okay. So what is a pointer to a pointer? We have seen so far pointer to an integer, pointer to an integer array. Okay. What is a pointer to a pointer? So if you want to store a pointer's address into some other variable, the pointer itself, that pointer's address you want to store, then you have a pointer to a pointer. Okay. So it's like this. A is an integer and integer variable. P is a pointer variable, pointer to an integer, and pp is a pointer to an integer. That means you need to hold the address of a pointer. So to hold the address of a pointer, you make use of a pointer to a pointer. Okay. So the indirection you can see this is going to hold the address of this. pp is going to hold the address of p. Okay. And the addresses of a, p, and pp are given. So this 1000 is the address of a, 2000 is the address of p, and 3000 is the address of pp. This pointer to a pointer is also known as a double pointer. It is also known as a double pointer. So one example to illustrate this double pointers. Okay. And like the double pointer, you can have a triple pointer. So what is a triple pointer? Triple star pointer name. Okay. First of all, the syntax is, if you have a single pointer, it will be single star p. if it is a pointer to a pointer, it is a double pointer. So pointer to a pointer to an int. That is star star q. And if it is a triple pointer, it is pointer to a pointer to a pointer to an int. It is star 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 r, third some other variable. Okay. So this p can hold the address of a. Q can hold the address of p, and r can hold the address of q. And if you just do this kind of a dereferencing, then you will get the appropriate values. Now for this, if I write star p, it's going to give me directly a. If I write star q, what will it give me? Use a dereferencing. Okay, it's going to give me p. What is p? P is a pointer.
Address of
Address of it.
It is address. It's going to give me the address of a. Okay, so I think this you will be comfortable understanding. So star star q. What is star r? What is star r? Star of address of q, right? Star r is star of address of q. That is q. And q is address of p. So this expression will give you the address of p. What is star star q?
Address of A.
Star star q is going to give me address of a. Star star r.
Star star Q will give A. Sorry. And star
Star-
R will give address of A, no?
Yes. Star star q is going to give me star star address of p. Okay, this gets cancelled out. That is star of p. And star of p is nothing but a. Star star q will give me a. Star star r is going to give me address of a. Right now?
Yes, ma'am.
And triple star r will give me the a value of a prime. Okay, so this is the concept of double pointer. So this is important. These concepts which I cover after this 2D arrays, they are important for your quiz. The concept you should know so that you are able to answer that quiz. Okay, so I want to cover two, three more topics which are left. So I'll cover that at 4. Fine. You all don't have anything at 4, right?
Ma'am, A2 and A1 have their maths tutorial
At 4?
Ma'am, 3
from
to
3
5.
to 5.
Yes, ma'am.
Okay. So tomorrow, no, tomorrow I am not free at that slot.
Ma'am, tomorrow we have ISC at that time.
Okay. Tomorrow, otherwise, I will take it. Yeah. In the morning, you slot, you are free. Give me one morning slot, otherwise. 8 to 9. One of the days, because I want to complete it.
Yeah, ma'am, that works.
Okay. So either tomorrow or day after. Tell me which day. I
Ma'am,
don't know.
tomorrow
Both.
we have 8 o'clock class on Thursday.
Okay. So tomorrow, both IT and electronics are free at 8.
Ma'am, can you try to keep it in the evening?
Tomorrow, I'm not free in the evening.
Like
Thursday,
7 or
I can
8?
take. 7 is not possible for me. At 8 in the evening, you'll be able
Yes,
to
ma'am.
understand. The concepts are going to get more advanced. That
Morning 8 is also.
Ma'am, morning it is also too early.
So see, in the evening you will not understand the concepts only. What's the point of taking that lecture? Because it's not that easy.